Good evening everyone. Today we will go for the second part from the window function. We should cover today a very critical part for ranking and dense ranking and row number. What is the difference between them? Then we will go for cumulative total and we will use our table for employee and salary and we will see how we can calculate that. Then we will go for a salary history and the trend by using lag and lead, which very two important concept in window function. Start by ranking. What is the difference between ranking, dense ranking and row number? Ranking, it will skip always the number if there is tie, so it will show you 1, 2, 2, 4. It means if we have two employees get the same salary and they are ranked in second, so it will give them 2 and 2 and then 4. Dense rank on opposite side, it will not skip it, but it will give 1, 2, 2 and then 3. So it didn't skip and jump to 4, it didn't skip a digit, it actually just gives the tie number, same figures, and then it go for the next digit and gives 3, normal. But what is the row number? Row number, on contrary, it always give a unique, and you can always remember it because it's a row number, so it actually focus on the row, it not focus on the value, and that's why it always created as unique. It's very important when you are trying to build an index. It could be very useful for such cases. Let's jump directly into action. So we have our table that we used from last time, which called employee, and let's now select the name, ID and salary, and let's show the difference between rank and dense rank and row number. So as you can see, we put all of them the same, all of them follow the same methodology. You need to partition them, so you say over. Okay, here in this case we use salary, so we don't need actually to partition, we will directly use salary for each and every row, and we need to order it by salary, so we have like from up to down, so we will use descending order, and then this is our rank. Then you can take the same in each and every one, and let's name it little different. So you see it's dense, rank, and then after that it will be row rank. And of course we need to put comma and comma and comma. So it's rank, and after rank you have order, so we order it by the salary because we don't need to do partitioning here. We can do partitioning by department, so we do the order based on department, but the target here is to show for the whole table, and that's why we jumped and we did the over, we did salary, but we order it by salary descending to show the highest to lowest. Yeah, okay. And now it should be 1. So we can see now the ranking. It's 1, 1 under ranking salary, then it jump 3 and 3. It's very important to notice it just jump by 1 digit, so it not because like 1, 1, then 3, 3 and then 5. So we can see here that after pop and lim they take 3 and 3, it jumped to 5. It didn't jump directly, for example, to say like 1, 1 and then 2, and then you can see on other side dense rank, it forces that it use every digit without it's like jump over, so it's 1, 1 and then pop is 2, Lima is 2, then Jack is 3 and 4, and etc. And it will never jump. Roll number, on contrary, it already ignored each and every tie, and you can see it just like go like an index 1, 2, 3, 4, 5, regardless what is the value on the salary table, the salary column. And that is very useful when you are trying to build an index. Now, if we want to use the same functionality from first part and second part, and we want to check the employee that is the highest in each and every department. So we don't need on the whole table, but we want to focus on each department. Here we will need to use partitioning, and let's see how we will do that. So select and then all from employee. Okay. Now we want to put first a rank that will rank based on department. So let's check row number and let's make it a partitioning over and then order by. Of course we need the salary again, but in this time we need descending order. So it's descending because we want the highest. Let's call it rank and let's run it. We can see that now IT and then sales, it's only one. And you can see now rank, you have the partitioning based on department. But because we didn't have partitioning, it didn't go for a specific department, it make 1, 2, 3 and 4 and 5 and etc. So what we need to do now is like do the partitioning. So we will say partition by department. Now if we run it again, we will see that finance 1, finance 2, finance 3, and then in HR 1, 2, and 3, and then now we have the ranking. Okay, but now I want the first in each department. I don't want all of them, I want the first. So we can create a simple subquery by select all, then from. Now we need to build like our demo tables that we will use like as a dummy table, which is this one, and let's call it ranking. And then from ranking, we now want to, we already selected everything ranking, but we need only the rank to be equivalent to 1. So we are simply saying for SQL, build first this dummy table, call it ranking, then go in this dummy table and take only rank equivalent to 1. If we run this, as you can see, we end up by finance first, he's Henry, first person in HR, Alicia, IT, David. They are the highest paid in each and every department. And by this way, you can see how window function could help you to save a lot of time, and with a very quick steps, you can reach specific and unique answers for tricky questions when you are building your analysis. Now the second part is one of the most important topics in window function, which is lead. So what is the difference between lag and lead? We created here extra table called salary history, and that will help us to clarify the both concept. Lag allow you to go to one row previous and use the data from the previous row. Lead allow you to use the data from succeed row. that mean the next row. Lag and lead both are used intensively in time series analysis and building trends and do a comparison or create a percentage of change over a time or a period. So lag and lead we can consider the most critical functionality for window. We run the table, we can see that we have here Alicia, Pop, Clara, and we can see over the years what is the increment that they get in their salary, and we will use the lag and lead to calculate for them first the percentage of a change in their salary, and then next we will see how we can predict or expect the increment based on the percentage we calculate. First, let's start by select employee ID. Then we will select name. We will select year, of course, because it's important to do the comparison, and salary, and now it's time to use the next salary. So I have the option to start by lag to check previous. I am compare between what is now and what is the past. So I say lag, and then parentheses, we put the salary is the target column that we want to do comparison based on it, and then we do over. Again, we need to do the partitioning. This time we are on individual level, so I'm focusing on each employee, so I will use ID. And I need to order it by year because I need to check the increase that happened during the years. So now we have the previous salary from the last year. Now we need to compare it to what she or he get at this year. So let's do comparison. We will make minus, and then we will use the same. So we first create salary column, then we have salary from last year, and then we will do the salary minus the salary from last year, and this will give us the increment that the employee got during this year. And all is coming from our salary history tables that we built. Table will be provided in the video description so you can use and download. You can see now that previous salary at beginning always will be null for each of them because we don't have previous history, but you can see that the increment from 46 to 48 it's 2, and then from 50 to 48 it's 2. So this was Alice increase during these years, and then Pop have only one increment. It was with amount of 5,000. What if we want to use the lead? So we check how much percentage of a change that took place for each of them. So let's use lead. Then we create. See here the percentage of increase. So when we use the lead, we exactly implement the same. We just divide it by salary so we can get the percentage. So simply the 2000 is divided by the 48, it makes 4.35. It's crucial to calculate the time series by do the prediction for the future using the lead based on that.